Hello everyone, welcome back to my channel. In this video, we will be continuing with end of chapter exercise for chapter 1 of class 9 mathematics. This is in continuation with our previous videos where we had discussed chapter 1's exercise 1.1 and 1.2. Let's continue with the end of chapter exercise. This is the graph sheet which we'll be using to plot points if required in any of the questions. Moving on to question number 1. It says, what are the x coordinate and y coordinate of the point of intersection of the two axes? So to answer this question, first we should know what is the point of intersection of two axes, right? Let's see this graph sheet for reference. This horizontal line is called x-axis, this vertical line is called y-axis, and what is the point of intersection of these two axes, which is the middle point? It is called origin. Let me write it down. Point of intersection of two axes is called origin, denoted by capital letter O, and its points are 0, 0. So to answer this question, its x coordinate is 0. Similarly, its y coordinate is also 0. Moving on to question number 2. Point W has x coordinate equal to -5. Can you predict the coordinates of point H, which is on the line through W, parallel to the y-axis? So see, if any line is given as parallel to y-axis, its x coordinate will always remain same, right? And in this case, the x coordinate is equal to -5. So how will this line look like as shown in this image? So point H can lie anywhere on this line, which will be either in second quadrant or in third quadrant. Point H can lie anywhere on the red line as shown in image, which will be either in second or third quadrant. Okay, moving to question number 3. It says, consider the points R3, 0, A, 0, -2, M, P if they are joined in the same order. Predict. Okay, so first I have plotted these points R, A, M, P on the graph sheet. Now let's solve this part number 1. Two sides of ramp that are perpendicular to each other. So from this image we can see side PM is perpendicular to side AM. PM is perpendicular to AM. Okay, coming to part number 2. One side of ramp that is parallel to one of the axes. Okay, so AM is parallel to x-axis, PM is parallel to y-axis. AM is parallel to x. Oh, sorry. X-axis, and PM is parallel to y-axis. Okay, coming to part number 3. Two points that are mirror images of each other in one axis. Which axis will this be? So mirror images are -5, -2, which is point M, and -5, 2, which is point P. Point P and point M are mirror images of each other. Okay, which axis this will be? So axis is x-axis. Okay, coming to question number 4. Plot point Z 5, -6. This is Z 5, -6 on the Cartesian plane. Construct a right angle triangle IZN and find the lengths of the three sides. So there are multiple answers to this question. I have shown one of the possibility. This is the way I have plotted this IZ and triangle with point Z as 5, 6, where IZ is of length 4 and NZ is of length 3. So by Pythagoras theorem, the hypotenuse length is of length 5 units. Okay, now coming to question number 5, what it says, what would a system of coordinates be like if we did not have negative numbers? Okay, would this system allow us to locate all the points on 2D plane? So, okay, let's see this graph for reference. So as of now, this is the Cartesian plane looks like, right? We have infinite positive numbers on x-axis, y-axis, and infinite negative numbers on x-axis and y-axis. But now it says if we don't have negative numbers, so how will it look like? We will have this origin same as 0, 0, and we will only have the infinite positive sides of x and y axis. So negative sides will not be there. So in that case, I don't think we will be able to plot all the points possible, right? Because it will be like we are standing at a crossroad and traffic man asks you to move only in the front direction or in the right direction, but that is not always the case, right? We can even go back side also and left side also. So if we don't have negative numbers, we won't be able to plot all the points. Okay, so the answer to this question, if we don't have negative numbers, we won't be able to locate all points on a 2D plane. Okay, coming to question number 6. Are the points m minus 3, minus 4, a 0, 0 and g on the same straight line? Suggest a method to check this without plotting and joining the points. Okay, so now to check if all the points are on a single line, there is one method called slope method, right? So there are 3 points given. We will take 2 points at a time and find its slope. Okay, so M, A and G are 3 points. Let's take 2 points at a time and find its slope. So if all the points lying on the same line, the slope will be same for every 2 pairs, right? So slope of MA. Okay, first let's take this M and A points and find its slope. Now how to find slope? It's y2 minus y1 whole divided by x2 minus x1. So y2 is 0 and y1 is minus 4. So 0 minus minus plus 4. So 4 divided by 0 minus minus plus 3. 4 by 3. Right? Similarly, slope of AG. Now this is point A, this is point 2. So 8 minus 0 is 8 divided by 6 minus 0 is 6. So this is also equal to 4 by 3 if we simplify 8 by 6, right? 4 by 3. Now again slope of, now what is the remaining pair? M and G. Slope of MG. So 8 minus minus plus 4. 12 divided by 6 minus minus plus 3. 9. So if we simplify 12 by 9, what it will be? We can divide the numerator and denominator by 3, right? So it will again be 4 by 3. So since slope of MA equals to AG equals to MG, hence all 3 points lie on a straight line. Okay, coming to question number 7. Use your method from problem 6 to check if the points R, B, C are on the same straight line. Okay, similarly we can apply the same logic to question number 7. So we will find slope of taking 2 points at a time. Slope of, let's take RB. So y2 minus y1, so minus 5 plus 1, it is minus 4 divided by minus 2 plus 5, which is 3. So slope of RB is minus 4 comma 3, minus 4 by 3. Now let's find slope of BC. Slope of BC will be minus 12 plus 5, which is minus 7, divided by 4 minus minus plus 2, 6, minus 7 by 6. Okay, so here we can stop because slope of RB is not equal to slope of BC, right? So we can say as slope of RB not equal to slope of BC, hence these points does not lie on a straight line. Okay, simple. Coming to question number 8. Using the origin as one vertex, means one corner of the triangle, plot the vertices of a right angled isosceles triangle. What is a right angled isosceles triangle? Okay, first, what is an isosceles triangle? Isosceles triangle is like any two of its sides should be equal. And what will be right angled? At any of the vertex, it should have a 90 degree. So this is the way I have plotted the 90 degree, means right angled isosceles triangle with one of its vertex as origin. Okay, so this was answer to part number 1. And second part, it is showing asking an isosceles triangle with one vertex in quadrant 3 and other in quadrant 4. So this is one of the way we can plot this. There are infinite answers to this, but this is one of the possibility. Okay, great. Now moving to question number 9, it asks the following table shows the coordinates of points S, M, T. In each case, state whether M is the midpoint of segment ST. Justify your answer. Okay, to find the midpoint of any two given endpoints, how we can do that? For x coordinate, we can add up the x coordinate of those points and then divide by 2. Similarly for y coordinate also. So if endpoints S and T are minus 3, 0 and 3, 0, so it's the midpoints x coordinate will be minus 3 plus 3 whole divided by 2, which will be 0. Similarly for y coordinate, 0 plus 0, 0 divided by 2 will be 0. So yes, in this case, M is the midpoint of S and T. Now coming to second one, 2 plus 4, which is 6 divided by 2 will be 3. Okay, this is matching. And y coordinate, 3 plus 5, 8 divided by 2, 4. Yes, this is also matching. So this is also midpoint of S and T. Coming to third one, 0 plus 0, which is 0 divided by 2 will be also 0. So this is matching. And 0 minus 10, which is minus 10 divided by 2 minus 5, but here it is plus 5. So in this case, this is not midpoint. Actual midpoint is 0, minus 5. Now coming to fourth one, minus 8 plus 6, which is minus 2 whole divided by 2, which is minus 1. So actual midpoint should be minus 1, 7 minus 3, 4 divided by 2, which is 2. But here it was given 0, minus 2. So this M is not midpoint of ST. Actual midpoint is minus 1, 2. Okay, coming to question number 10. Use the connection you found to find the coordinates of B given that M is the midpoint of A and B. Okay, so A and B points coordinates we need to find, and its midpoint is given. So 3 plus x whole divided by 2 is equals to -7, which means this whole divided by 2 we will shift to right hand side, so it will be x plus 3 equals to -14. X plus 3 equals to -14, which means x equals to -14 minus 3 -17. Similarly, we will find y coordinate, I mean value of y. So y minus 4 whole divided by 2, this is equals to 1. This means, so this divided by 2 we will shift to right hand side, so it will be into 2, so y minus 4 equals to 2. This means y equals to 6. Okay, so we found the value of x and y, so point B can be written as -17,6. Okay, moving to question number 11. Let PQ be points of trisection of AB, where P closer to A, Q closer to B. Using your knowledge of how to find the coordinates of the midpoint of a section, how would you find the coordinates of P and Q? Okay, so India point A and B are given. So the easiest way to find the coordinates of trisection is, first let's see what is the change in x and change in y happening between these two endpoints, right? So A and B are the two endpoints, and in between these two we have to plot another 2 points P and Q, which should be equidistant from each other. Okay, so what is change in x? Equals to 16 minus 4 equals to 12. Similarly, what is change in y? Change in y is -2 minus 7, which is equals to -9. Now this is the total change, but we have to find change in one trisectional part, right? So change in x in one trisectional part, this will be equal to, just we have to divide the total change in x divided by 3, as this is trisection, right? So 12 divided by 3, which will be equal to 4. Cool. And similarly we will do for y also. Change in y in one trisectional part. Okay, -9 divided by 3, which is equals to -3. Now our job is very easy. So first trisectional point, which is point P, this will be equal to, we just need to add 4 and -3 to its previous point, which is point A. So point P will be this point A is x coordinate plus 4, so 4 plus 4 will be 8, and 7 minus 3 will be 4. Okay, similarly next point will be Q, and its previous point is P, right? So we have to add 4 to its previous point, which is point P. So 8 plus 4, which is 12, and 4 minus 3, which is 1. Now just for testing purpose, I will again add 4 and -3 to point Q, and let's see if it is matching point B or not. Okay, so 12 plus 4, which is 16. Yeah, it is matching, and let's match the y coordinate also. 1 minus 3, which is -2. This is matching. So that was the solution to question number 11. Coming to question number 12. So it had two parts. Let's see one by one. Given the points A, B, C, show that they lie on a circle K whose center is the origin. Okay, so if we have to show that point A, B, C lie on a circle, so they all have equal distance from its origin, right? All will be equal to its radius of the circle. And to find the distance between any two points on Cartesian plane, this is the formula: square root of x2 minus x1 square plus y2 minus y1 square. Okay, so let's see what is the distance between OA. Okay, square root of x2 minus x1, so 1 minus 0, which is 1, and square is 1, and minus 8 minus 0, which is minus 8, and square is 64. So this is the root of 65. Okay, similarly, what is distance between OB? This is square root of 16 plus 49. What is 16 plus 49? 65. This is also root of 65. Okay, now let's find distance between OC. This is square root of 49 plus 16. Yeah, this is also same, so root of 65. So like all OA, OB, OC are same, so we can say that point A, B, C lie on a circle, and the radius of the circle will be root of 65. Okay, now coming to part number 2. Given the point D and E, check whether D, E lie within the circle, on the circle, or outside the circle. Okay, so the logic is very simple. We will find distance between OD and OE, and if OD is coming less than root 65, so that means D lies within the circle. If D is equal to root 65, means D lies on the circle, and if OD is greater than root 65, means D lies outside the circle. Okay, so let's find OD. So OD will be root of 25 plus 36. What is 25 plus 36? Root of 61. And root of 61 is less than root of 65, right? So we can say that D lies within the circle. Okay, similarly, let's find OE. OE is root of 81, which is 9. So okay, let's write it as root of 81 only, which is greater than root of 65. So we can say that E lies outside the circle. Okay, now coming to question number 13. It asks the midpoints of the sides of triangle ABC at the points D, E, F. Given that the coordinates of D, E, F are this respectively, find the coordinates of ABC. Okay, so let's say D is midpoint of AB. Similarly, E is midpoint of BC. Okay, and similarly F is midpoint of CA. So when we say D is midpoint of AB, how we can write it in the mathematical form? So we can say D equals to A plus B divided by 2. Similarly, same way, E equals to B plus C divided by 2. Okay, and same way f equals to c plus a divided by 2. So if we add, so let's consider this as equation number 1. Okay, this as equation number 2, and this as equation number 3. So if we add all these equations, adding equation 1, 2, 3, we will get d plus e plus f equals to a plus b plus c. Okay, now from this we can deduce a equals to d plus f minus e. Similarly, b equals to d plus e minus f. Similarly, c equals to e plus f minus d. So if you are wondering how I got these equations, it's very simple, right? So if we have to find a with relation to def, what you have to do in this equation, leave a as it is and just replace b plus c from this equation number 2. So what will be b plus c? It will be 2e, right? Now when you send 2e to the left hand side, what it will become? D plus e plus f minus 2e, which will be d plus f minus e. So similarly you will get for b and c as well. Okay, now we have found a, b, c with respect to d, e, f. Now we can find the coordinates of a, b and c. So now what will be a? It will be d plus f minus e. So d plus f minus e means 5 plus 0 minus 6, which will be minus 1, comma 1 plus 3, 4 minus 5, which will be again minus 1. Okay, now point B, this will be d plus e minus f. Okay, so 5 plus 6, 11 minus 0, which is 11, and 1 plus 5, 6 minus 3, which is 3. Okay, now to find point C, this is e plus f minus d, means 6 plus 0 minus 5, which is 1, and 5 plus 3, 8 minus 1, which is 7. So we have found coordinates for point A, B and C.